Hello, guys. Welcome back to another episode. As you can see, today's episode is going to be a little bit different from our normal episodes where we're doing 3D modeling and going through certain CAD softwares and stuff. And that's because I really wanted to expand this channel to talk about multiple different topics, not just CAD modeling and designing and stuff. I kind of really want to dive deep into other aspects of design and engineering and other stuff like that. So, if you're not familiar, right in front of us here we have a PLC program. Um, and this particular software is actually Mitsubishi PLC software. It's actually the GXWORKS3. So this video is really going to be kind of tailored to people looking, um, you know, for PLC programming and also maybe even more specific Mitsubishi PLC programming. And basically, a PLC is a programmable logical controller or a programmable logic controller. And basically, these are the brains of a lot of manufacturing and plant environments. So instead of hardwiring everything and using a set of relay switches like we used to use many, many years ago, now we have PLCs, which give plants the ability to program and make changes, um, using inputs and outputs. So if I use a switch to turn something on, it'll turn on a VFD, for example, that will actually control a motor. And then from there, if you want to switch that, to a different speed or a different setting or whatever it may be, you can do that kind of on the fly. So that's kind of just a simple basic background. If you clicked on this video, I'm just going to assume that you have a little, you have that basic knowledge of what exactly it is, and you're kind of just looking forward to learn more about it. Um, I chose Mitsubishi PLC and GXWorks 3 because, first of all, it's what I use for my work, and then second of all, there's tons and tons of free available resources, not only on YouTube, but on Google also, and many other places for Alan Bradley. So whether it's Walrus Logic 500 or Studio 5000, all them resources are there. There's almost a never-ending amount of resources, but when it comes to Mitsubishi PLC, whether it's GX Developer, GXWorks 2, or GXWorks 3, there's just not much resources, and if you are able to find some resources, it seems about 90 to 95% of the time it's never in English. So if you're in the United States and you're looking to learn it, you're kind of just reliant on using a manual or just kind of learning on your own, which is fine. Today's topic of the video is just an exercise for us where basically we want to program the PLC to turn on a set of lights, three lights for 1 second, and then those lights turn off, and then another set of three lights, so lights 4, 5, and 6 will turn on for 1 second, and then basically those lights will alternate it back and forth. So they'll turn on, then off, and then on, and then off. And then whenever that main switch is, you know, turned on, first of all, it'll, the lights will flash. But when you turn the switch off, all the lights will turn off. Um, so here is one of the programs. I've actually made three separate programs, but we'll go over this one today as it's kind of more of, you know, a little bit of a beginner to maybe even somewhat of an intermediate program, but it's a very simple program. And it's the one that I found for me that uses the least amount of what we call rungs here. So the idea, and please keep in mind in the comment section if you want anything specific with Mitsubishi PLC, we will start posting on the channel. But also, if you have anything specific you want to learn, um, please comment below and we'll try to get that video out to you. Just keep in mind that I am not an expert and I am constantly learning just like everybody else. So just keep that in mind. So the main idea of our program is up here at the top, we have an X1, which Mitsubishi, that's just an input. Y's over here will be our outputs. And then these M bits here, if we click on it, see M1. Our M bits are kind of internal memory bits, so they're not really associated with any kind of actual, switch or motor or LED. They're not really associated with a physical address or a physical um, thing that it's trying to control, but it's more of like an internal memory bit. So the idea, it goes like this. Reading it, of course, ladder logic, it's from top to bottom, from left to right. So when we power this switch on, this internal memory bit 1 turns on. When this bit is on, it'll turn on this timer. So the main idea for me is I can keep this short by putting a timer on here for 20, um, which is basically just 2 seconds. This is a K is a constant. TO is a particular timer. So we have an output of a timer on for 2 seconds. Um, so whenever that internal memory bit comes on, this timer will turn on for 2 seconds. But the main thing is I decided to separate it between 0 to 10 to 10 to 20. So if it's less than 10, I want a certain set of lights to come on, and if it's greater than 10 and still less than 20, I want the other set to turn on. So the set of 3 for the first, and the next set of 3 for the second. So if the timer is less than 10, and right here you can see and X1, or the switch, and the switch is on, turn on M10. So all M10 is if we come down a little bit further in our program, M10 is basically an internal memory bit that powers on the outputs Y1, Y2, and Y3, which we directly have wired up as LEDs. Now, as soon as that timer goes over its 1 second, or its value of 10, um, technically the timer would be greater than 10. So when the timer is greater than 10, and we know that the timer is going to turn off at 20, but when it's greater than 10, or 1 second, M20 will turn on. Keep in mind up here, when this timer is over 10, this M10 is actually going to turn off, so these lights will turn off. And then once it's greater than 10, this M20 bit will turn on, or will energize, which will actually turn on or energize our Y4, Y5, and Y6. So we have LED 1, 2, and 3, and then 4, 5, and 6 both separated, um, both separated as 2 kind of different subsections. Lastly, in the program here is whenever that timer is done, so when it reaches its value of 20, we're going to reset the timer. Once that timer resets, it'll actually go back down to 0. So when that timer goes to 20, of course, these will turn on 3, the other ones will turn on 3, the timer will reset, and go back to 0, and then these 3 will come on again, and the process will complete as long as this bit stays on. As long as this X1 stays on here, as you can see, as soon as it turns off, the everything will turn back off. So what we're going to do is we're going to make sure it's built, and we're going to come up here to our start simulation in the GX3 software. You can see it's actually going to kind of write this to the PLC, the simulation PLC, and then from here we can actually toggle this X1 bit on, and we'll see these lights flash on and off. So a quick thing to toggle is just a Shift Enter. And we'll try this again, Shift Enter. So we toggled it on. You can see here it's on, and now you can see these lights are going back and forth here. Watch as when 10 comes on, the first 3 turn off, and then when anything greater than 10 comes on, the second 3 come on. So now I will turn this off just to verify that everything turns back off, which it does, and start it again from scratch. So that was just an example of a PLC program that I suggest you practice at home. If you have any questions, please ask in the comment section below. Thank you.